So today I'm going to show you a skill that honestly, you're not going to necessarily make use of this a lot in the future, the X and Y intercepts definitely, but we are going to show you something that you have to get used to doing, and I'll explain that when we get to it. But it's called symmetry. What is symmetry? What does that mean? Something symmetrical. Same on both sides. Actually, if you were to test to see whether or not your face is symmetrical, you might think it is, but people's faces are generally not symmetrical. So I'm going to show you examples of 3 types of symmetry, and then you're going to learn how to test for them. Mr. Banks is going to put away his phone because he knows that that's not important right now. Okay, and I'm going to start by using what we did yesterday, which was finding our X and Y intercepts. Do you remember how to find your X and Y intercepts? Yeah, suppose we plug in 0 for Y and 0 for X. If I start by plugging in 0 for Y, what do you get? You get -4. If you plug in 0 for X, you get Y squared minus 4. Yep, so +2 and -2. Yep. So we've done that before, right? And so you could very easily and quickly sketch this graph. I just plot 1, 2, 3, 4. 1, 2, 3. You can see that if I mark +2 and -2 on the y-axis, and then -4 on the x-axis, what shape does it make? A parabola that is sideways. So we say that this is symmetrical about the x-axis. And what that means is you could flip it and it makes the same shape. We all good with that? So how do we test to see whether or not something's symmetrical? You plug in -y. Okay, and that's the skill that's going to be used 2 other times throughout this year that you need to get used to doing. So we want you to get used to this algebraic piece. So suppose I didn't see the graph. You're wondering, is this thing symmetrical? Well, you take x is equal to, and instead of y, you have a -y. What happens when you square -y? Yeah, you get y squared, right? So we get x is y squared minus 4. Is that the same as what we started with? So therefore, it's symmetrical about the x-axis. Okay. Yeah. For the next one, if you want to find the x and y intercepts, again, you can plug in 0 for x. If you plug in 0 for x, what do you get for y? You get 0. And if we plug in 0 for y, 0 equals, I'll factor out an x squared, and I get x squared minus 3. Anybody know the solutions to that equation? That's just 0, which we have. And then anybody know what I would have here? Close. So if we do x squared minus 3 is equal to 0, you get x squared is equal to 3, which means x is equal to plus or minus the root of 3. See that? So positive root of 3 and negative root of 3. Yeah, the decimal of the square root of 3 is 1.73. You've all memorized that. Good job. And so as I plot these points, I have x values of negative 1.73, positive 1.73, and 0. And the graph actually looks like this. Okay. We say that that's symmetrical about the y-axis. So can you see if you were to spin it on the y-axis, you get the same thing? Yeah. Okay, and the way we test for symmetry on the y-axis, anybody want to guess? Good. Plug in negative x. So I'm going to do that right now. Y equals, I have a negative x to the fourth minus 3 times negative x squared. I plug in a negative x. That's what I'm looking for on the test, is that you know what to plug in. What happens if you take a negative to the fourth power? Positive. So y equals x to the fourth. And then the negative x squared will be a positive x squared. It'll be a minus 3, so minus 3x squared. Yeah. So there we have, it's matching, so this is symmetrical about the y-axis. And the last one, if you plug in 0 for x, what do you get for y? 0. That means it passes through the origin. And if I plug in 0 for y, 0 equals, I'll factor out an x, and I get x squared minus 1. So what are the solutions to that? Yep, so I have a positive 1 and I have a negative 1. So I'll sketch that graph. And that's what the graph looks like. You're not necessarily supposed to just know that it looks like that. I'm just, in chapter 3, you're going to learn how to graph these polynomials quite quickly. You'll be very good at it too. We say that this is symmetrical about the origin because if you were to flip it 180 degrees, it looks the same. Now I always try to get this perfect every year, and I never do. Oh, I don't want you to flip that one. I want you to flip the graph. Let's see what I get. I'm off, aren't I? Yeah. Well, thank you. That's nicer than a lot of my classes are. You can definitely. Yeah, I know. I'd have to shift it, wouldn't I? But if you flip it, do people get the idea? It looks the same. Flip it 180 degrees. That's the idea. And so how we test that is very simple. We plug in. Very good. Negative x and negative y. And this one is important for you to notice. I replace y with negative y equals. I replace the x with a negative x, and I cube it, and then minus a negative x. Some of you have very sloppy handwriting. Some of you have very large handwriting, and it starts to kind of interfere with one another. It is best when you're plugging in a negative x to place parentheses around it so I know what you're doing. Otherwise, sometimes we just make things disappear, and it's hard to tell. So this stays negative y. What does this become? Negative x cubed. And then plus x. Is that the same as what I have above? Is it or isn't it?
No, because you can't change it. You have to leave it.
Can I multiply through by -1? Is that a legal thing to do in an equation, maintain equality? Yes, it is. And so I get y is equal to positive x cubed minus x. So now we say, yes, it is the same, symmetrical about the origin. Yeah, that's all right. Everybody see that? Okay. So we want to determine whether or not these are symmetrical. So I'm going to test the x-axis. What do we do to test the x-axis? Yeah, so it's 2x, and then it will be a minus 3y is equal to 0. Is that the same? No. So it's not symmetrical about the x-axis. I'll plug in a negative, or what do I do to test the y-axis? I plug in a negative x. What will the equation look like when I plug in a negative x? Negative 2x plus 3y is equal to 0. Is that the same? No. So it's not symmetrical about the y-axis. What do I do for the origin? I replace both x and y with the negative. And what will you get? Negative 2x minus 3y is equal to 0. Is that the same as what we have above? Why? Because you multiply through by a negative, and it is the same. So yes, it is symmetrical about the origin. That's it. So, what's that? No, you don't have to sketch a graph. I just want you to be able to, and again, knowing whether things are symmetrical does help you generate ideas about the graph. But this idea of plugging in negative, it isn't just for this unit. It comes up again, and it's very useful. Now, somebody said, so will it always be one of them? No. Well, watch what happens here. If we test the x-axis, what do we plug in? What do we plug in there? A negative y is equal to 3x minus 5. Is that the same? No. Let's try the y-axis. What do we do there? Y equals a negative 3x minus 5. Is that the same? No. Yeah, and when you do the origin and you do negative y is equal to negative 3x minus 5, sometimes people might be like, oh yeah, that will be the same because if I multiply it through by a negative 1, it changes the 3x to positive. But it also changes the 5 to positive. So this has no symmetry at all on the x-axis or the y-axis or the origin. So in this case you had 1, in this case you had none. Anybody guess what the case is for the last one? Why? Because why not? I like that. That's good. Yeah. Who cares about reason? Let's just go with what our gut says. I like it. We plug in negative y. We get 2x squared plus 3 times negative y squared is 4. So yes, because we get 2x squared plus 3y squared is 4. So yes, this is symmetrical about the x-axis. Do you see that the same is going to happen for the y-axis? Yeah. So for the y-axis, we plug in a negative x. And lo and behold, we get a positive 2x squared plus 3y squared is 4. So yes, it's symmetrical about the y-axis. And how about the origin? Yes, because 2 times negative x squared plus 3 times negative y squared is 4. Those will all go away. 2x squared plus 3y squared is 4. And that's it. So the worksheet that I have for you is the front side of what you did yesterday. Last year there were 10 problems. Now we just do 6 because you're so wonderful. Dressed up in all cherry and blue. We should really get a picture. Oh, from yesterday? Do you have the... Yeah.